So I'm a chemical engineer, graduated from the University of Toronto back in 1982. And then I worked for Exxon for 3 years. And I was mainly building pilot plants for the Sarnia facility in the refining area. And then from there, I moved on into a completely different sector, which is biotechnology. And I'm currently actually making, making freeze-dried blood. So we're using a cryogenic process that was developed with my colleague, my good friend and colleague, Matteo Forgione. And I work with Forgione, actually. I'm the process guy, and he's the mechanical guy.
Is it the same university or collaborating universities? You're at the same university? I know he works part-time.
And we're at the same university. Matteo and I are both part-time professors at UMass Lowell.
Mm-hmm.
I'm in chemical engineering and he's in mechanical.
So Matteo was quite involved in our windmill design. He's been involved in the patents for a while.
We're very interested in the one patent that you have, the one on the geothermal. The one on geothermal. I become interested in a network geothermal. It is a project that has been going on at UMass Lowell for the past 4 years, and this is to be able to use water, like to draw water at a certain temperature for heating houses and businesses, residential.
So I think you had a good understanding. We spent a couple hours having lunch, and it sounds like you might try to take that to the Calgary company. Your sister works at the Calgary company. Is she an engineer there, by the way? Is your sister?
Oh, she's not an engineer. No. She's a journalist.
A journalist.
Yes. She covers the oil and gas. She's retired now, but she covered for about almost 30 years the oil and gas industry.
She's older than you.
She's actually younger than me. She's actually younger than me. Younger and much prettier.
Okay, Mauricio, thanks for the introduction. And Mehdi, why don't you give a quick introduce yourself?
Mehdi is an engineer working in London, and originally got my degree from Iran, Shiraz University, bachelor, master, and then PhD. Part of PhD was at Western University. Came back again, part of the postdoc, working on a couple of things, and then created my own company like 2018, working here, in the building industry mainly. But I'm interested in deep foundation, and that's why I got connected through a friend to Martin. So my field of research was in deep foundation, and I also teach part-time at Western, a couple of courses, on BIM, building information modeling. But yeah, my main field of research and interest was or has been deep foundations.
Jed, Mehdi also could do the slope stability analysis. He'd be in this category of Matt Janes. Matt Janes is a very experienced practical engineers who I don't know if he'll make it or not tonight. I think Andrea will join us, but we'll go ahead and start scrolling the PowerPoint you got there, Jed, and I'll talk.
Yeah. All right.
Welcome to another episode of the Contractors Innovation Podcast, sponsored by CH Shotcrete Inc. We're happy to bring you these podcasts in an education and knowledge sharing format. And we look forward to hearing from you. Email me at martinh@footprintengineering.ca. God bless, and may you have a wonderful day.
There, it should be up there. Can you see it?
So yeah, I can see it. So these are patents that I've created in the States and in Canada. I have several more actually, but they're all similar in the sense that the good ones are in both areas. So go ahead and flip that.
Apparently, it's not going to. Just bear with me here.
By the way, this is the Contractors Innovation Podcast. It'll be a proper episode. Please hit the like and subscribe button if you're watching this or will watch it in the future. Hit like and subscribe, please. So an overview of available patents, some pricing structure, and go ahead, Jed. Next. So we haven't sold anything, but in terms of our previously sold, it was a previous version was called R4. So next. So we have probably our best patent is called the FEBTU cell. And I think that was something Mauricio understood very quickly. And the advantage of the FEBTU cell is, unlike other geothermals, it runs on clean water and uses the power of evaporative cooling to create, superior air conditioning, which should work out well in Texas, where I'm targeting the ultimate sale. Go ahead. This is a heavy-duty heat exchanger, and the outer foot is clear gravel. So what we would do is we'd have a water furnace, which would build 30 psi, maybe, water pressure. And then we could control flow it to the gravel. And the evaporative process in the gravel would result in a chilling of the heat exchanger. The advantage of this technology is there's no impact. Go ahead. Your question? Go ahead. I can keep going? Yeah. So evaporative cooling for a high COP. So geothermal, typically, some of you may be familiar with glycol systems. They go down 200, 250 feet, 300, 600 feet in Toronto. There's been many done recently. They do one a day. Quite often with glycol, they can freeze the soil. So when they obviously freeze the soil, then that's a problem for performance. And the best you'll get is a COP, coefficient of performance, of 2.5. So next.
And what does this one give us?
We can get 5. Andrea and I are working on up to 7.5. That heat exchanger in the middle there, if you follow the flow of the water, we think we can make that with 4 chambers and get up to 7.5. Now I think the real value of this system is with a caisson drill. You can drill in clay 5 units a day, 30 feet deep. Whereas 1 a day with a lower COP, the proposition, it's quite expensive. And it's, the prospect of ground freezing, our system will never freeze the ground. And doing 5 units a day at the bottom of an excavation is attractive to developers. Ultimately, you think about the owner. So there's the outer gravel, and then the kind of this idea of the water pressure overflow. So that outer gravel is controllable. I think it's about 2 gallons per ton per hour is the math that Andrea supports. And again, my company, CH Shotcrete, is going to have Canadian rights to this after we sell the American rights to the patents. Go ahead, Jed. We'll keep going. So another nice thing, I realized that when I had the stiffness of the heat exchanger, that I could put a windmill on top. So then you end up with this idea of an ideal off-grid device where you could literally have, we've test sited one in Godrich that had a 10 kilowatt. There's the drawing there, yeah. So that's a vertical axis blade windmill that was made with aluminum. Our new design, Matteo and I have worked on is steel blades, and you try to learn off the first one, and we probably don't need that much power. We probably only need we need to have the fit and finish, and you get about 300 RPM out of one of these windmills, but that's called a wild wind windmill. And so the idea of a FE wind, or what we call FE Geo Wind HD, is really the advanced version of where we're going with this. If you go up to the just below that red line one, there you go there. Now that's the early version when I started. And what I did is I put concrete between the outer casing and the inner pipe. And then I suspended an active water table. Keep in mind that you would feed water in to keep it potable, and then that water would overflow to the outside. But now the heavy duty heat exchanger development, we can use the pressure in the actual water furnace tube. Like that tube would be a 20-inch 313 wall HSS hollow structural. And so it's easy to bleed water off into a thicker gravel layer. If you have the ideal ground is really clay. You don't really want to be drilling in Godrich. I hit a high water table, and it made for some interesting tests. But you can see that we've developed it to the point where we have a belief that we can develop these heat exchangers, ship them to sites, and put 5 in a day. That's my goal. And I know a caisson drill, what it can do. And the nice thing too, Maddie, is you'll understand this being a foundation expert. It's scalable. So you can go to any size with caissons, right? You can drill a 9-foot, you can drill, keeping in mind that your outer borehole is containing the gravel, the actual soil, or you can get into a number of sleeves. But I've developed this idea that you don't need any concrete, and that's meant to make it modular and shipped to site. You won't need to have concrete on site. So next slide. So, okay, FEH2O lock. The best way to think about this patent is a waterproof wall. And in Toronto, what spurred me to do this was how things were done in the 80s. I remember how they were done in the 80s. And, we used to put caisson wall, secant wall next to buildings for stiffness. And we used to do lagging, wood lagging away from the building where the stiffness wasn't critical. And we did 4 or 5 underground levels pretty routinely, sometimes more. But what happened in Toronto is they went through a period with the development where the downtown treatment plant, which is Ashbridges Bay, they said that they didn't want any combined storm and sanitary put into the system, because normally you just take whatever leakage is coming through your excavation support system, your weepers, and you put it all to a sump, and then the sanitary and the sump combine and go to the treatment plant. They said, we don't want that load. So they started making everybody tank the basements. So that meant that they literally built 16-inch walls and raft slabs that were 2 meters thick. And they stopped using caissons in the bottom. So this innovation, FEH2O lock, you can advance the slides there, Jed. That's a waterproof wall. So it's a double bypass shotcrete wall system. And this is actually, I have a sample here of a spigot. So this spigot is a 4.5-inch 375 wall HSS section. I started doing that at my last company. But when I left the last company, instead of a single bypass system, which we would do in Hamilton or London, or not so much in Toronto. Next slide. So this is the first test.
Yeah, I think that this went back to the windmill one, sorry.
That's okay. So here's the first water table one, right? Now, you wouldn't know all the issues with the stiffness, but clearly I can't have a joint in the middle. If I could go above the concrete, not have a joint, and then go right to the windmill, I wouldn't necessarily have a wobble in the windmill. So now my heavy duty heat exchanger reflects the fact that there'll be no wobble. I'll go to 1-inch casing, 1-inch pipe, 1-inch end capping. And the key is to make it heavy duty, as long as you can create a gravel layer on the outside and overflow the gravel from that water furnace. So it's a heat pump, but it's a water furnace heat pump. Next slide, Jed. So, okay, we're already onto that, eh? So the FEH2, by the way, do you have a section of FEH2O lock? You don't, eh? The 2 layers are, there might be one somewhere, but we'll go on to this next patent. But so basically what I did, and I mentioned this to Mehdi, is I took a 18 at 55 pile, and I welded tabs, somewhat like these tabs, on the front of the pile. And then smaller holes, but I'd put a 15M bar in that. And then I would mesh the front, and I called it bypass shotcrete. So I created a bypass shotcrete system. And for the patent, I added another layer, another 5-inch layer, but I put in an 18-inch, here we go. Thanks, Jed. So this is called a feather edge. That's actually the main claim of the patent. It needs a wood float. You stagger the joints. Well, that won't leak. And if I use chem concrete, which is my plan, that's a new world patent actually done by some Iranians out of Western Sydney University. Very smart guys. And it's a 5 hybrid nano. So what it's going to do is change the concrete industry, because, the best you can get from waterproofing is really a Crichton or a Zypex, which are billion-dollar Canadian companies. They sell all over the world out of Vancouver, but there's crystalline companies everywhere in the world. But the chem concrete is a world patent. And instead of 30% waterproofing, maybe 35. You can see the joint there, just stop there. So that there's a spigot. So this, by putting another 5 inches on, I'm able to cover that nut and permanently encase that system from leaking. What I call an anchor spigot A detail. So it's a solid wall. Now the advantage of that, Mehdi and Jed, is that you wouldn't have any blindside waterproofing, particularly with chem concrete, because chem concrete goes to 95% waterproof, and it's actually affordable. They use the 5 nanotechnology in the waterproof admixture. The websites are up, chemconcretecanada.com, which I was instrumental in. Now you see this detail, the 2 5-inch layers. If you had a situation where you were spacing your piles, you might put an extra filler in if the ground was at all not cooperating. But you see that you got a vertical drain there. Now, Nader Ansari, a famous engineer in Toronto, owner of Isherwood, would often say the rate of evaporation of soil in Toronto exceeds the rate of leakage. So as long as you can get leakage down that drain board, then you end up never getting water to the weepers. You'll never get water. A drain board itself has void in it, and so you're not going to get any water. And so you can get rid of the raft slabs, which are a tremendous savings. I mean, with mass concrete, there's a detail with 3 anchors in my spigot, and these would be pretty realistic anchors. I use a lot of R-bar, typically R-bar or T-bar thread. You drill grout through the anchor. And so those would be our 63s. We used to be able to get 600 feet a day with a TI 320 drill that we bought TI drills out of Colorado. And with the feather mesh, so I'm quite confident that I can give a 15-year waterproofing warranty on that. It'll probably never leak. So, but you see the tabs on the piles, and there's this spigot I held up a little while ago. Again, you got 2 layers instead of 1 layer with the single bypass system, which was the double bypass system is what I patented after I left the company. And you can do 30-inch or 35-inch, 40-inch anchors. This is an interesting patent. And Jed and I share in this one. It's something I did fairly recently. So I love gravel as an engineering material. And if in this case, I like MST rebar as well. So the MST rebar is glass bar, which opens up all kinds of possibilities to put the glass bar in gravel and not have it go anywhere. So we made a Z bar, and the Z bar, when you put it in the hole, you just lean it over and you fill the hole up, just pack it with a 4x4. And then the Z bars, or typically an MST, there you see a pattern of mesh in there. You always put gravel underneath the slab, and then you tie that slab in, those Z bars in to a mesh in the slab, 2-way mesh. So then you end up with a tied down slab. And, we believe, there's almost no need for frost walls, although by code you have to put those things in. So what we would do is pack that 3-inch gravel layer beyond the work area. And then we'd edge form the slab, which becomes a pretty easy process. And then we would, you could see it going in lifts there. And then we would basically cut that vertical from the compaction effort, you'd cut it, and then you just put your styrofoam. Do you think that should work, eh, Jed? We talked about that at the time, I think.
Yeah, yeah, that's exactly how that one works. And then you
Yeah.
have with the Z bar in here, you have no uplift here because that's all tied underneath the gravel that's packed in lifts, and then gets tied to our mesh system, our MSD mesh system that right here, shown right here, all throughout the concrete, and then gets encased in concrete, and get a bunch of those around your pad, and there's no up. That eliminates the uplift of everything on top of it.
I think what this could do, Mehdi, in an Amazon warehouse is you wouldn't need interior pad footings. When you think about it, why do a pad footing in the interior to hold a column when you could vary the thickness of the slab? You got incompressible gravel. Jed talks about mesh, but he means grid. It's really a grid. And
Yeah,
you
like
could
the mesh system. Yeah, sorry.
you could tighten the grid up into 8x8. You could increase the bar sizes. It's a very, very useful product. MST Rebar, Bornea, who's a part owner of that business and really the president and the key guy, CEO, he does 400 million a year in North America with that bar.
Why clay soil? It only works with clay?
Well, anywhere where you can drill open. So, you don't really want the difficulty of running liners. Like in caisson work, if you're going to have water, then it's always a level of concern that you pour concrete in the dry or even place gravel in the dry. But what we would pick this system for is clay. And in Toronto, it's a post-glacial area. Almost everywhere is clay, and below the clay is rock. So you could drill the rock. I mean, you could use a BG24, and you could put these things in a 1 million square foot warehouse, and there'd be no reason to do pad footings to hold a column, because all you'd have to do is increase the thickness of the slab, particularly with high strength. I think I expect chem concrete for that, because it's a tremendous product in the sense that you could take the same amount of cement and get 10 MPa more. It would probably be a 10-inch slab, but if you put an anchor or even 12-inch, if you took anchor bolts, I don't see why a column would need a pad footing. On a typical warehouse, it's 40-foot base spacing. It's a practical feel that I apply to those things, but you got to sell it to the structural engineer, and it takes a while for things like this to be accepted. But I think you understand it, Mehdi, eh?
Yeah.
Yeah. So by all means, use it, introduce it at some point. We would like just so you could do you could put up to 3 bars in a hole. We visualize. Well, you could use basalt, but I mean, really, I think MST rebar is more cost effective than basalt. What they do, Mehdi, is they pour glass fiber in a hopper, and they melt it down. It extrudes out like a hot rebar with through a die, and then they just have to bend it hot, because you can't obviously bend it cold the way you do rebar. But rebar is really a shitty product, and this fellow's got a great product. He was a composite engineer from the University of Waterloo, and he got backed by the Gaspress money in Toronto. So they've got 300,000 square feet there, and he's doing, I think, 300 million a year. Quite effectively. You could buy 20-foot bars, Mehdi. You could buy 20-foot bars, like 10M, 15M, in bundles. And it's, I would highly suggest you integrate it into any slabs you do. Because if you do that, because the stiffness is 4 times, I think it's 4 times the strength, but it's definitely stiff. So my vision is you don't have to saw cut the slabs. And when you saw cut, you don't have to saw cut the slabs. The MTO in Ontario uses MSD rebar in the bridges. So if they were to start using chem concrete in the bridges, you could end rehab for bridges. But as long as concrete's porous and they don't have, they typically would use air and train concrete. But with chem concrete, you don't need air and train.
What would the road salt do to chem concrete though? Have they done it? Is there any studies on that yet? Because I feel like that would be the biggest factor
Well,
in doing bridges with chem concrete with no rehab is the salt is effectively what's destroying the
well,
concrete.
I guess, do you need air? Do you need, does air do any good? I would say no, but it's chlorides, right? But if you get rid of the rebar and you get rid of a lot of the expansive damage that's occurring within the bridge that used to occur, and then if you get rid of the permeability, if you actually shut down the permeability of the concrete, when you pour chem concrete on a sidewalk, it beads water. So you won't get any penetration of the salt.
Okay.
In
I didn't know
theory.
over time if it would eventually
Well,
wear
well,
through, or I know it's not a surface, it's not a surface layer that you add, right? It's mixed right into the concrete coming from the plant or
yeah,
whenever it's poured on site kind of thing.
it actually comes as a yogurt. They're loading 40-foot or big containers and they ship it from Australia. But conceivably that process could be done in every country. They're just QCing it for now. But the yogurt, I guess, it becomes easy to mix and hard to reverse engineer. That's the way I think that they're probably thinking. Because if you get that reverse engineered, people will just steal your patent. Patents are going to be hard at that level to defend. But I thought it was interesting that when you pour chem concrete on a slab, it beads water. So you can't let any salt in, Jen.
Okay. All right.
That's the answer for that. Do you have something else there, Jen, on the slideshow? Well, the panel support system. This is what Mauricio's been waiting for. So
Yep.
this is a snow melt curb. I had this happen in Clinton where I had panels sitting there and I watched the panels be useless all winter a couple years ago. So I developed an aluminum curb. And I don't know how good the drawings are, but the aluminum curb, I've got proper fabrication drawings for it. But I put 4 panels in the curb. I've got 4 of these curbs on my house. And then as it turns out, the aluminum box is 1 foot high and the panels fit fairly tight. And the sun alone on the box keeps the snow from melting. But I did there you see that you've got an end plenum, and then you end up with the ability to exhaust, like to power the air into the end plenum. And so there'd be a duct heater and an axial fan. So there's any number of ways I've been thinking lately that almost any heat at all, Mauricio, would work.
Oh, okay. Yeah.
If you put snow melt cables in there, it would work. Something that might be a little less bulky because you got to get below the roof line. In my building, I planned it out to put 4 curbs and some of the hardware. It's all aluminum, and my roof's fairly high, but I also never get snow on the curbs. And it's like the 1 foot box heats up. So I don't bother running the fans below it. It's
Well, that's optional. The fans is optional.
yeah, like I always have, I've got about 1100. I got some substantial batteries. So my batteries are always full. There's sort of a diagram. This is done by my patent agent, I think, did these drawings. And yeah, it's patented.
Yeah,
And
do you mind sending me the number, the patent number? It's Canadian patent, right? Oh no, it's a
well,
US patent.
there's the US patent number right there.
Okay,
So can you see it? Can you see it there?
I can see it. Yeah, it's
I
okay.
think you,
It's recorded,
yeah,
so I can go back to the recording.
very good. I'm glad for
Yeah.
the benefit of Zoom. Anyway, well, is there another? I love talking about these patents, so the I think that in Texas we have a lot of potential for because of the heat, and the Texas is all clay. So okay, here's another patent. This one here is I was approached by Verde Alliance, who's a big former conglomerate in Toronto. They've combined, 5 companies have combined, but when Verde was Verde, Lawrence Rigotti, one of the estimators, was asked by 407, can you come up with something? Because what happened with 407, when they built 407, they put standard culvert in. They never thought, oh, we should think long term with that culvert. So with a standard culvert, it's usually 0.5 or 5 millimeters of and so what happens between 4 and 7 o'clock is you get from the water running through the culverts, you get rust. So then they say, oh, what are we going to do? They started putting 1-inch HDPE in every culvert, and they would shut down the side of the road and they would lift this HDPE tube in and they'd slide it in and grout it. So they asked me if I could come up with something for that. And I came up with 2 patents. And I used Matt Janes actually to model it. He used Plaxis to model it. And we were successful. They wanted 75-year life. So this is the FEHD plank. So these are HDPE planks. And they would come, 6, 8, and 10-inch. And you could put them like click flooring. We made like a joint that would slide them together. And next slide there, Jed. So, and the other patent I thought of this was, when you're kids, well, we use basaltic rope here. So you can buy basaltic rope in 1/4 inch, 5 millimeter from China. So it's a double Dutch skipping rope. So I envisioned that 6 men could do 100 feet a day. I have a lot of experience with men, so I think that was accurate. But in the end, the 407 said, oh, well, we're just going to keep doing what we're doing. And I think the guy was being paid off by Verde, but nonetheless, he ended up pretty senior guy with Infrastructure Ontario. So I why would the guy change his mind? Why would he make but I have the patents now anyway. So these are drawings that Footprint Engineering with Matt James's help assembled as illustrations of how these patents work. Here's another patent. This is an interesting one. This is FE Heliogen. And so if you have, let's say, a system, Maddie, where you're doing secant walls, I call them secant walls, so the interlocking walls, what would you do if the water table was let's say the cut was 30 feet and the water table was at 35 feet. So I thought of this pattern where you would instead of taking luffer casing and driving through to create a seal at 50 or 60 feet, all you do is drill the easy part open, and then you would put oh, here's Andy now. Andy.
Hey, what's the link? Nobody sent me the link.
Nobody sent Andy the link. Can you send him the link? Let me see. I'm sure I sent it.
I'll forward it here.
This is good because we want to. So you see here, you basically have a helical pile, and that saves you from putting secant or sectional casing in below a water table. Because if it's dry to here, then you can use the dry condition of the upper soil and hang in there, Andre. Are you driving with your wife? I don't know if you can hear me now.
So are you Martin? Are you talking to me?
No, I'm talking to Andrea Kumanovsky, the heat exchange engineer. It'd be good for you to meet him though, and
yes,
he works with Pickering and the Bruce, so he does all types of small heat exchange analysis for the contractors.
okay.
He's a master's in and a specialist in heat exchanging. So FE Heligent is conceivably you could run FEH2O lock details and do FE Heligent, but
I will. Yeah, my.
are Andy's on now, eh? Okay, we go. Okay.
Hey, Martin. Hey, folks.
Hey, Andy, thanks for making it.
Of course.
Andy, tell us a little bit about yourself while you got the mic.
Yeah, no, I support Martin on the mechanical side of work. So that includes FEBTU cell. I'll put my camera on as well. Am I visible?
Yep.
Okay. Yeah, I support him on the mechanical side. So that involves all of the geothermal heat transfer, thermodynamic side with his patents, and of course he specializes on the ground drilling side of things. So together we've been working on the FEBTU cell and that's the main one really, but I'd love to contribute a bit more with this. So yeah, when we talk more about that, I don't want to derail the FE Heligent, so we'll come back to
No, that's good. We're done with the Heligent. That's a fairly basic explanation. Stay on, Andy.
Yeah, sounds good.
So listen, something I was thinking about with this, and sometimes things. This is actually an advanced version that Andy and I think if we could pass water through down 1 up to down 3 over to 4, we think we could get this return on energy to 7.5. Now, Mehdi, you can imagine this heat exchanger is removable, which is interesting, right? You could remove it. You know, if you put that, it's got gravel around it, and you decide I'm moving off this property. You know, you could take it away, right? It's kind of an interesting idea the way it's mobile. Again, with the FE GeoWind connection, we think it's a free energy device, I often call it. But Andy, talk a little bit about you've got some. I know on my websites I have your memos, but tell us a little bit about what is it, 2.2 gallons per hour per ton? And
Yeah, that figure sounds right. But of course it scales depending on the tonnage. So our system, depending on whether you have like a 5 ton or a 10 ton or sorry, 5 kilowatt, 10 kilowatt, or 15 kilowatt FE wind turbine, we're able to size the FEBTU cell accordingly. So it really depends how much excess water we have, whether you have any at all. And
well,
in
we
the case of,
probably
sorry,
and
Martin?
it's probably going to run on potable water. Is that what you mean?
Yeah,
Like
you don't.
it's not going to run on. We're not going to have a water table to work with. I mean, most of the soils in Ontario are dry.
Yeah,
So
and you don't even need it. That would just be an extra benefit, which would then help avoid the ground battery situation. So a lot of the issues with geothermal is that every single year, especially when you have like an uneven heating and cooling season where one is much longer than the other, you end up with a situation where the ground just becomes too hot, for example, over or year after year to absorb more heat. So then your ability to cool a space significantly reduces. So if you're somewhere like maybe Oregon, like the kind of the dry side of Oregon, but like down low, or in California, something like Palm Springs, um, your ground situation would just become warmer and warmer. Whereas this allows us to have the efficiency of a ground source heat pump, but um, with the benefit of evaporative cooling, so that over time you kind of start being able to get rid of a lot of that heat straight to the air. So you can use the infinite thermal reservoir of the airspace, as opposed to the finite amount of ground space that you would be dumping heat into. So, but
you're
it,
talking
it
about
does
the gravel, right, Andy? The gravel.
the gravel, I mean, sand, whatever. In our case, it's gravel, right? But it's the gravel helps us evaporate a lot of that water and heat, so that the ground over many years doesn't get warmer and warmer, and you don't lose your ability to cool your house effectively. So that's one of the benefits.
I believe are independent of ground battery because of the nature of evaporative cooling. I can't
Yeah,
imagine.
exactly.
You know,
As long as we have that dry, it's not too humid where we're putting it. Yeah, so it's definitely a plus on our design.
Mehdi, this would be very effective in Iran, eh? So
Yeah,
you
probably.
probably.
I'm not
And
very familiar with the like geothermal, to be honest.
Oh no, it's
Yeah.
typically ground freezing is an issue, and ground battery can be degrading over time. So we believe that this has potential in these shorter units to be engineerable and scalable and removable.
Yeah. I know there are like 200 feet deep, the geothermal that they installed. Am I right?
Yeah, that would be true. Like in Toronto, they drill 300 to 600 feet deep. But what we would do is we would drill 30 feet deep.
Yeah, this is interesting because with 30, because I know that like the cost for drilling is like around 70, 80K
And
just
and
for,
you're and you're drilling with glycol, which is an uncertain uh, material. I mean, if you have leaks in glycol, they might say, "Well, we fixed it." Well, or they just pump glycol in all the time, right?
Mhm.
It's a very environmentally unfriendly system. So we think this is a game changer, and we hope that the U.S. will be able to put it on the map. One of the things we're going to offer, I do have a targeted company in mind, and they do design build, but one of the advantages, Mehdi, is we have really good design build people. We have yourself, we have Matt Jays, we have Isherwood. you know, we would do design. Toronto's a very design build market, probably more than any other market in North America in some ways, just the way it developed. You know, some great entrepreneurs over the years, and Italians, you know, they put it together.
Have you ever tried this one on any project, real project?
What FEG?
The geothermal FEGO wind.
Just my own property. The problem with my property was I had a high water table, so it was a nuisance. It was, but we've learned a lot on it, and we've learned to that our windmill needs to be refined. And now Matteo Forgione has developed FEGO Wind 2.0. So this is 1.0. So I don't even run this system right now because my solar gives me my 4 solar curves give me all the power I need. But I learned a lot. So I filled this pond up so I could stiffen this joint, so I could run this windmill to the 300 RPM speed that's required.
So yeah, like this water is this water that we're showing here around the
Yeah.
windmill pipe is
Yeah.
what you're seeing.
That's
that.
right. And that's not really going to be done again because if I can get picked, it would be geotechnically only in clay that our system would work. But most sites are clay. You know, it's very rare that you get piping sands. Godrich is right on Lake Huron, so it's got all types of things there. But in any case, I'm off grid. I'm just finishing my diesel generator, and anyway, that's. I think we're at a pretty good point to wrap up. Jed, thanks for your slideshow, and Andrea, thanks for making it.
Oh yeah, guys, before you go, very quick, in the chat, I added kind of a 7-page storyboard, which will give you a bit more info on the GeoWind as well. Before you leave the meeting, I recommend just if you don't have time to take a look, just download it and take a look after.
Yeah, and we have your emails, so it was good that you made it, Andy.
Okay.
Oh,
Did you just put it in the Zoom chat here?
yeah, I just put it in the Zoom chat.
I don't see it.
Yeah, me too.
No?
No.
Then what I'll do is I'll email all of you. Actually, let me see if I could share my screen.
You can.
I can't?
Yeah, you can. You've just hit the share button down there.
Okay, I think it's starting.
There we go.
You
Yeah.
guys able to see?
Yep.
Okay, that's weird. Let me just find it again. It's right here. No, that's the wrong one. Just 1 second. It's right here. So I'll just reopen it. So you guys can see it?
Yep.
Yeah, can you want to walk us through it quick? Just how many slides are there?
Just 7. So it's kind of very minimalist approach to what I wanted to convey with it and kind of the vision that I have. So it's a new kind of cogeneration. You have that kind of stackable system where you have the wind turbine up top, you have the FEBTU cell at the bottom. And if you compare solar to this, it's about 9 times the power generation concentration per square footage. So instead of like something like rooftops would be good for solar, but rooftops you could also use for like growing crops. So in any case, you want high density of power generation wherever you can. And in something like this, you could see how to the left and to the right, you could grow crops. Whereas for solar, you would need to cover the entire, 9 times the area of that to generate that. Of course, it has its own caveats, like you need to be in perhaps high enough where there's enough wind, etc. But definitely has certain use cases. And then of course the FEBTU cell with its gravel and evaporative cooling benefits. So, and then as I go down, kind of, I had a vision for how we could maybe even put this on top of buildings, and that also benefits in the sense that it's more likely to have high wind. And if it's too fast, you could always throttle it, but so it's never really an issue. If something is spinning too fast, you could control that. And then, it could be installed anywhere. It could be discreetly installed to ground. It could be at the ground as well, but I was thinking like somewhere up top where you have a lot of wind. You could also use the elevator shaft. I thought of that after I did this pictogram, so I just added that note afterwards. It almost looks like a centerpiece, like in a wedding at the center of a table, you have like a flower pot. Similarly, this is how it could be used, and it could be prefabbed in many shops. It doesn't have to be a very custom place, as long as we give them the parts and we form some sort of agreement with them. And it's not really something that, because it has more scaling potential, it doesn't have to be massive like some of the other turbines that people are used to. Oh, the other thing, when I built this, there was that whole discussion about the rain tax. And the rain tax exists, and correct me if I'm wrong, I guess because the city's now processing your properties, like rain in the sewage. But if you're evaporating it, then you have good grounds to avoid the rain tax because you're basically putting it straight back into the nature. So you're facilitating additional evaporation while reducing the ground battery effects over time, especially if you're somewhere like California. And you get a bit of a cooling load boost from the surface temperature dip. I did in my memo, I did a mass transfer proof of that. Let's see, through diffusion. So cooling for cooling season, snow melt. Yeah, I mean, during heating season, it's a little bit different. You might need some makeup water, but it's a lot of places have gray water that's being used without any purpose. But at least here, again, another way to reduce the rain tax. And then in something like a ideal home, like a single family dwelling, almost like a house, could also work. You could put it in the backyard. We're seeing payback periods of 5 years, where the expectancy is 50 years plus. Of course, the designs meet all the ASME, CSA, Fire Code, and BCC. And because, again, it's ground source, more efficient than air source, but has the benefits of air source thermal reservoir, the infinite thermal reservoir of the ambient. And then just the last two slides showing an AI-generated version of that, though honestly, I think this looks better. This looks a little bit more dead for some reason. But anyway, full transparency, I still think it looks pretty cool. There are phone numbers there. And then at the very bottom is the actual picture at Martin's site on a very beautiful clear sky day. Super low noise. It blends in with nature, even during high rotation. And it is a formidable step towards a more sustainable future. And then at the bottom, we have Martin's site. So
Yeah, that was my question. I didn't know what's the sound. So it's pretty quiet then, eh? It doesn't make a whole lot of sounds. Like, do you got to grease it? What's the main maintenance that you got to do on it?
Got a sealed roller bearing,
Okay.
but so
Is
it's
it still
meant to be.
possible to email it?
Yeah,
Email presentation?
yeah. Well, we can certainly give you this. You're going to see this podcast, but yeah, I agree. This document, Mauricio, would be
Yeah.
useful
Yeah.
to get by email. Can
Yeah.
you do that? Can you do that, Andrew? send that to,
If you just forwarded, if you forwarded me that email I just sent you to get you to join the thing, I can forward to everybody else.
Okay, great.
Yeah, that works. Its intention was to be technical, but also like emotional from a vision point of view. So, yeah, I'll send that over.
okay, well, how long have we been, Jed?
About an hour.
That's pretty efficient. I don't have anything more to add. And, but
So
what we can
what
do,
does that, so what would that system cost? Like the one you have at your house, Martin, if we had a client that wanted to install something like that at like say up north, just to kind of get off the grid up there.
I would think that, you wouldn't put it where there's a high water table. You
Okay.
know, caisson equipment is you know, off the scale if you have to seal casings the way
Yeah.
I got into. But if you I think we were dealing with a windmill from Mateo that was 15 grand US.
Okay.
And then if you put that, I like the concept that Andy put in with putting it within the building. So for instance, if you had a 2 or 3 story concrete building,
Yeah.
then you'd end up with a concrete shaft. And
Yeah.
all you'd do is you would put your evaporative cell there and you'd have a water furnace right next to it. And you'd end up with an amazing air conditioning in the house. Like when that thing ran at my place, which is the furnace is not far from here, from this room, the duct, the power of evaporative cooling, the duct frosted over like it got frosty.
Hmm.
Because you know that's the nature of water when it evaporates.
Yeah.
You know, it's a powerful thing. And I think we got Andy, who's you know, interested in the science as well as, you know, available to almost vet stuff, Jed, right? In a
For
concrete
sure.
building.
Yeah.
So it ends up being useful that you've met him now. So Jed does a lot of work. Well, Jed, you didn't really introduce yourself, but for the benefit of everyone here, you do a lot of stuff with modular homes.
Yeah, well, I mean, anything small buildings. I'm a BCIN certified designer, so anything under 3 stories and 650 square meters I can design. So new builds, renovations, additions, I do lots of the modular home communities, the foundations and the CSA approved, like the 27 or A277 model homes. We get those plans and placed onto our pads and all that fun stuff. But yeah,
Well, hopefully we'll do some of those FE slant gravel piles.
yeah,
You know, that I think that that's got a lot of potential
yeah,
because
for sure.
when you put gravel under the slab, you basically just have to make sure the water is directed away, right?
Yeah.
You don't really need to have 4-foot footings.
No, for the modulars, we don't do any of the 4-foot footings. They're all either concrete pads or gravel pads themselves. So it's right there, yeah.
Yeah. And what's your website, Jed?
Designforlife.ca.
Let's see. Okay, and I'm gonna think that we've done a good job, guys. Thanks for all your help.
Yeah, thanks for having me.
Thank you so much. Thank you.
Mauricio, have a happy life melting snow now.
Yes.
Take care, my friend.
Take care,
Take care.
guys.
It's been nice.
Baby, I need to know.